Students, today we will study eddy currents. As we have already studied Faraday's laws of electromagnetic induction. So we have studied that whenever magnetic flux is changed through a coil, induced EMF is produced. So this induced EMF not only produces in a coil, but also when we change magnetic flux through a disc or some pipe, then it again induces EMF in that very portion of the coil or sheet. So today we will perform a simple experiment showing how this is a bar magnet. I have a neodymium magnet with me. It is a very strong magnet. So first of all we will try to pass it through a plastic pipe. So just you will see how long it will take to cross this pipe. So just I am going to drop it through the pipe and see that how fast it come down. So you will see it will just taken just a second to cross this pipe. So if we pass this magnet through a aluminium pipe, I have this aluminium pipe, so it is have a similar bore of that of this plastic pipe. Now let us see. So I am just dropping this magnet into this pipe. So observe the time taken by this magnet. So I repeat again. So time taken by this magnet through this aluminium pipe is much longer than the time taken by the magnet through this plastic pipe. So this is due to the eddy currents. So now we will explain that how this happened. Let us make this diagram of aluminium pipe, and we have dropped a tiny magnet through it. Let us suppose that the magnet has its north pole, the lower pole is north and the upper pole is south one. So what we will expect that the magnetic lines of force are coming out of this north pole and entering the pipe. So as soon as the magnet enters this pipe, the magnetic flux through this aluminium pipe changes, and as a result of that, induced EMF starts circular eddy currents through this pipe. We have studied Lenz's law that whenever magnetic flux changes, then the induced currents are produced in such a way that the currents oppose the cause which produces them. That is, they opposes the flow of magnet through this pipe. So when magnet comes through this pipe, the induced currents opposes the flow of the magnet. So that's why these currents move in such a way that they will form another north pole as this magnet goes down. But if we see that when the magnet is here, so its north pole is down and south pole is upper one, the currents on the surface of the pipe will be opposing nature down there, but attractive nature over the magnet, so that they can attract the south pole of the magnet, and the lower currents will be forming the north pole so as to oppose the downward motion of the magnet. So this is how the magnet from this aluminium pipe slows down while moving down. So So if we pass this magnet from a plastic pipe, it will just come down. So this is the demonstration of eddy currents, that how it is formed in a aluminium coil. So this was the experimental demonstration. I hope that all of you enjoyed this practical.